Have you ever found yourself constantly replaying an event over and over again, unable to escape the negative memory of what happened? Hi, my name is Parker Riley, and today I'm going to talk to you about a recent discovery. The discovery, a new molecule which may be able to explain why we associate events with positive and negative memories, was discovered during the summer of 2022 in early August. The discovery was made by Dr. K.M. Tye of the Salk Institute and her team. Dr. K.M. Tye is a BRRF Scientific Council member, a winner of the 2016 BBRF Freedom Prize for Exceptional Basic Research and the 2013 BBRF Young Investigator. In this speech, I plan on going deeper into why we have memories, why we tag memories with the emotions that we do, and how this new research and discovery may affect you and even possibly help you. Memories are one of the things that make humans unique. We are able to foster the past inside our minds and almost relive certain events in our head whenever we want. With that said, not all memories are good, and many people probably wish they couldn't remember everything that's happened to them, especially the really bad stuff. In the past, we used the so-called tagging system to help us hunt and stay alive. Remembering places where there was lots of food or remembering the dangerous places was essential and how we survived. We would tag those memories with a positive or negative reaction in order to remember why those memories had purpose. Now, however, we use those emotion tags differently. In a quote from the article, researchers identify a molecule that orchestrates association of events with positive and negative memories in a range of psychiatric disorders, including depression, anxiety, and post-traumatic stress. People can fixate or rely to an unhealthy degree on memories of negative experiences and emotions. In the language of neuroscience, such individuals tend to accentuate or keep in mind memories with a negative valence. Experience that may have contributed to formation of such negative memories may indeed have been painful or fear-provoking. The problem comes when the individual fixates or stresses the negative to the point where it impairs normal functioning in life. We have evolved to the point where our memories can actually cause harm to us. We can become swallowed by our negative memories, replaying them over and over again in our head, unable to stop until it becomes all-consuming. In some extreme cases, even affecting the health and well-being of the person, and even those around them. In 2016, Tye discovered that a group of neurons in the brain's basolateral amygdala, also known as the BLA, helps assign valence when mice are learning. One set of BLA neurons was activated with positive valence as the animals learned to associate a tone with a sweet taste. A separate set of BLA neurons was activated with a negative valence as the animals learned to associate a different tone with a bitter taste. The group would then use this discovery to further their research on the effects this particular neuron has on a human brain. As Dr. K.M. Tye said, "We found these two pathways, analogs to railroad tracks, that were leading to positive and negative valence, but we still didn't know what signal was acting as a switch operator to direct which track should be used at any given time." The group then decided to use CRISPR, a gene editing approach to selectively remove the gene for neurotensin from the cells. Without neurotensin signaling in the BLA, the team discovered that the mice no longer associated the events with positive memories, but would still associate the other ones with a negative memory, showing that the brain's default setting was fear. However, the team also learned that high levels of neurotensin promoted reward learning and dampened negative valence, further supporting the idea that neurotensin is responsible for positive valence. As postdoctoral fellow and fellow author Hao Li said, we can actually manipulate this switch to turn on positive or negative learning in the mice. Ultimately, we'd like to try to identify novel therapeutic targets for this pathway. In conclusion, the hope for this new discovery is that someday we will hopefully be able to increase levels of neurotensin in people's brains, just like they did in the mice, and that by doing that, we will be able to help people deal with their negative memories. The memories won't go away or change, but the idea is that they won't be so powerful and overwhelming. The extra neurotensin will change the memories to be fuzzier or less damaging, potentially really helping those who suffer from PTSD or extreme anxiety. So if there was a way to move on from a negative memory you can't escape, would you be open to trying to change it? Would you let somebody add neurotensin into your brain?